Okay, so good evening, everyone. So this is the last live session for this course, structure dynamics. So in this session, we will solve two problems. But one problem related to the equation of motion, like we need to develop the equation of motion for the system, and the another problem is that we will solve for the multi-degree of freedom system, in which we will solve using all the finding out the response at the each floor. So two kind of problems we will solve, and if you have any doubt you can get back to me, or you can ask any from any doubt from the discussion form. So for this, let me start first share my screens, so that let me share my screen. Is my screen is visible? I hope it is visible. So this session is for. Okay, so in this problem we will have a uniform disk which mass is m1, and it's connected to that disk is connected that disk is connected through a rod, which is we call connected through a rod EC, by which rod it is connected to AD. It is a hinge form AD. So this mass EC is a massless. This rod has no mass, so this is a massless, and the rod AB has the mass m2. Okay, the disk roll without slipping on the horizontal surface, and the beam rotate about a friction pin at A. Okay, so this is a hinge point, or we can say pin point. So use the displacement u, like if we give a initial displacement u to the disk at point E as the displacement coordinate. When u is equal to 0, the springs are taut but are unstressed. So for that case, we need to develop a equation of motion, and then we need to find out the damping coefficients. Okay, so for this we will make a free body diagram. Okay, if I will apply a unit displacement u this, so there will be a force developed through this, there will be a force applied to this rod. Okay, like if I will give a unit displacement, then this disk start to rotate, start to rotate, and if it start to rotate, then this will go to this bar going this side, and that apply a force at this point C. Okay, so for this we will make a free body diagram of this, and then if I cut a section at this point, if I cut a point a road at this, so in this, to make the equilibrium, it will having a reaction like this. Okay, so let us suppose we will calling this as a R. So I will make a free body diagram of this system. So first I will take about the disk. Okay, first we will take about the disk, so in which, so let us draw a disk. Please bear with my handwriting. Okay, so that disk, if I apply, we are applying a u displacement to this, mean it is traveling a u distance, which mean, and the radius is r, which mean it is traveling a u distance, so that angle, so if I will we will apply, and that mass of this disk is m1, so the inertial force will be applied to this in the opposite direction, so that would be the I alpha. Okay, and that disk will rotate. When it will rotate only if there will be a friction force will be applied in that direction. At that time it will be rotate. Okay, and there is a stiffness force which is attached to at point E. That force would be in the opposite direction, and that force is the k1 time u. Okay, and that we have cut a section at the road EC, so there is a force R is applied at that point. Okay, and the inertial force of this that was the rotational high alpha, and there is one more that is m1 m1 u double dot. Okay, so what are the forces will be applied at here? So for this, first I will take moment about, let us do the moment me about 0. Moment 8 e should be 0, so for that I can do what, I will take the moment about this e, so that will give me the f time r. Okay, minus I alpha. Okay, so if I will put it to be equal to 0, so my f will become as a I alpha time r. Okay, so what is the value of I for this? So for the disk, for the solid disk which mass is m1, so for this I is m1 r square by 2, and that alpha is the angle, actually alpha is the angle, so that angular acceleration. Okay, so that alpha will be given by u double dot by r, angular acceleration, that is actually theta, and that alpha is the angular, so that theta is given as a u by r. So your angular acceleration would be the alpha is equal to u double dot time r. So if I will put the value of alpha into this equation, we will get this as a m1 r square by 2, alpha as a u double dot by r, and 1 over r, so that these value will be cancelled out, so that will remain as a m1 u double dot by 2. So this is the value of f frictional force we are getting at that point. Okay, so after getting the f, we can find out at that another equation we need to apply at the disk, that is the f of x is equal to 0. So for this, those forces will be the r plus k1 u plus m1 u double dot. Okay, plus f is equal to 0. So if I will put the value of each and every component, so that r will be same, k1 u1 u would be same, m1 u double dot would also be same, and f would be the m1 u double dot by 2 is equal to 0. So if I rearrange the terms, I will get r is equal to 3 by 2 m1 u double dot plus k1 time u, so that term will multiply with the minus 1, so that will become, so this is our r. So from this we got a value of the r, expression of the r. Now we can make a free body of the, this is a free body of plate, or you can call it as a disk. Now we are making free body of rod AD. Okay, so if we, like if this point, because we are giving a u displacement at point E, so at point C this point also has the u displacement, so this bar will, like, will deflect like this. Okay, at this point is u, so that angle is theta. Okay, so that angle theta, so what is the value of that theta here? So that theta is given here as a u divided by, that is how much that length, it is a l by 2, so that will become a l by 2, so that become 2l by 2u by l. Okay, so uh, so we can write it as a, so it let us draw the free body diagram, so it would be easier for you to understand the things. So initially it was a straight, okay, and then it was going like that, okay. So this has the theta rotation. So at the l by 2 distance we have the damping force, okay. So that would be applied at a, how much damping coefficient, it is a c, okay, c time the whatever the displacement is, we can write it as a u, or we can write it in terms of the theta as well, okay. So damping is applied at, damper is applied at how much distance, at l by 2, okay. So not l by 2, it is applied at the l by 4, okay. So that would be the theta l by 4 times theta, so that force would be the l by 4 into theta double dot, okay. And then similarly we have applied a force at distance height, at height of l, so that would become l time theta, so that force become l kl theta. Similarly we have applied that force r, which is come from the disk r, which is applied at l by 2, don't go with the scaling, because go with the only the nomenclatures. So that l by 2, so that distance, the deflection is l by 2 times theta, so that force is applied as a r time l by 2 into theta. Is there any other forces which will be applied? Anyone? Am I audible to everyone? Okay,
Yes, sir.
okay. So now there is one more force, that would be the inertial force, that is the I time theta double dot. So for the rebar, for the road, I is ml square by 12 for the center, okay. And if I will take about the ends, it will become as a ml square by 3, okay. So now I can take a moment about point a, I can do the moment point 0 about point a. So let us write the equation, so that is the I theta double dot plus k l theta time l plus c l by 4 theta dot into l by 4, and another is the minus r l by 2 theta into l by 2 is equal to 0, okay. And that k is here k2, c is the c, okay. So let us put the value, so here m is m by 2, so your I at the end it becomes as a m2 l square by 3, so that is the m2 l square by 3 plus k2 l square theta plus c into l square by 16 theta dot plus, I will replace the value of r, so that r is in terms of the minus, so that will be minus minus plus. So if I will put that value, so it will become as a 3 by 2 m1 time u double dot plus k1 time u into l square by 4 theta is equal to 0, okay. If I will further simplify this equation, so if I will take the equation of those, that will be theta double dot also here. So I will keep those value, together. So that would be the uh, sorry, because we have done a mistake. So this is r is the reaction, so we do not need to multiply it with that. So that would be simply r. Okay, so that r is simply multiply with this l by 2. So that would be multiply with this simple l by 2. Okay, so if we do that, uh, so that would be the m2 l square by 3 theta double dot plus 3 by 4 m1 l into u double dot. Okay, one term is that. Another is that if we do for the k value, so for this that would be the k2 l square theta plus k1 l time u. Okay, and that another term is that cl square by 16 theta double dot is equal to 0. So now we can replace your theta. So our u here, our u was what? So we need to replace that theta with the u. So we have to replace this. We have to find the relation between this u, this particular u, and that theta. Okay. So if we find out that, so that is what theta is. We are getting 2u by l. So our u would become as a theta l by 2. Okay, so one is that, and u double dot will be the theta double dot l by 2. Okay, so we need to replace those things into the equation. So keep this keep this is as it is, m2 l square by 3 theta double dot plus 3 by 4 m1 l, and u double dot is what? U double dot is the theta into l by 2. Okay, so that become theta double dot into l by 2. Okay, similarly for k2 l square theta would be same, and that will be k1 l into u will be replaced as a theta l by 2. Okay, plus cl square by 16 theta dot is equal to 0. Now if we do that summarize, like again, so that will be become 3 by 8 m1. Okay, plus it will become as a m2 by 3 into theta double dot plus this equation become as a k1 by 2. So that l by 2 would be there. One more thing. Okay, so that would be the k1 by 2. So that k1 by 4. Okay, plus k2 into theta plus c by 16 theta dot is equal to 0. L square is cancel out. Okay, so this is our final equation. This is our equation of motion. Okay, so if we replace it, we need to find out the damping coefficient. So for this, let us rearrange this term again. So if I will do that, multiply with the 16 in the equation, 3 by 8 m1 plus m2 by 3 theta double dot plus c into theta dot plus 16 into k1 by 4 plus k2 theta is equal to 0. Okay, so that is that equation. Okay, so I need to find out the c critical, which value is 2 m omega n, or not 2m omega n, or we can write it as a 2 square root of m into k. Okay, so m is what, here m is, this is the total, and the k is what, that is a total one. Okay, so c critical would be 2 into square root of 16 times 3 by 8 m1 plus m2 by 3 multiply by 16 into k1 by 4 plus k2. Okay, so let us take outside 16, 16, that would be outside, so that would become 32 times, you can write it as a 3 by 8 plus m1 plus m2 by 3 into k1 by 4 plus k2. So this is your C critical damping coefficient. Now if you need to calculate the damping ratio, so for this you need to C divided by C critical, and here in this equation our C is this C. Okay, so your C would be divided by this equation, 32 square root 3 by 8 m1 plus m2 by 3 into k1 by 4 plus k2. Okay, so this is all about the first question. Any doubt in this question? Anyone? Any doubt?
No, sir.
Okay, if not, then we are moving to the last question. So that is a very simple kind of question, but very long question. So in this, the shown frame consists of a steel columns, which is E is equal to 2 into 10 raised to power 11 Newton per meter square, that are simply connected to the ground and they rigidly connected to the floor. Floor may be assumed to be rigid, like in a shear frame building. The tributary masses are shown. The column moment of the inertia are I1 is equal to 84,000 centimeter power 4 and I2 is equal to 42,000 centimeter power 4. Column may be assumed inextensible. The frame is excited at the base by seismic excitation with the shown 5% damped response spectra. Assume damping to be 5% in the all the modes. Okay, so we need to first develop the equation of the motion, and then we need to find out the model properties. After that, we need to find out the peak drift due to the seismic excitation, and then the peak internal forces in the exterior first story due to seismic excitation. So in this equation, so we have that this one is the first story, this is the first story, and that is the second story. So in the second story, there is one more column is collected. Okay, so only, otherwise it is a very simple question. Only that we have the one more column is attached to this, so that's why we need to solve this. How do we main, if you generate develop the equation of motion, then it won't be that much difficulty. Okay, so for this, to develop this, you can make this system like, if you do not want, if you are having confusion, so you can make a system like this, and there is a one more spring is connected to it, like that. This kind of equation is that. Okay, so for this, so we so for let us first write the what are those equations and the stiffnesses for those systems. So for this we have the stiffness k1, so let us write it is a k1. Okay, for this it is a k2, that is a k2, and not for this is k2 and this is k3. Okay, so if we make the stiffness equation simply, like if you remember the how do we, so that is the symbol k is equal to k2 plus k3. If let us suppose k1 is not there, let us suppose k1 is not there, then it will be k2 plus k3 minus k3 minus k3 and k3. But if we have the that k1 is there, okay, so what effect it would be? It would be in the like that, it will deflect like that, so that will be also deflection, so it would be the parallel combination. So in the parallel combination, that would be the add up k1 plus k2, so that one more stiffness would be added it here, k1. Okay, so this is the stiffness matrix for this. Now another for the mass matrix, so the mass matrix would be the remain same like the earlier we have the, so that will be m1 0 0 m2. So first we need to find out the what is my k1, k2, k3. So the k1, as these are the pin supported or the fixed, so for the pin supported we have the stiffness as a 3 ei by l cube. Okay, so for this, for the first story also it would be the 3 ei by l cube, but for the second story, because it is rotation is not allowed at the both top and bottom, it would be the 12 ei by l cube. Okay, so for this, if we write k1 is equal to 3i by l cube. So if I put the e is same, I only the I is different, I1, and the length is different, L1. So if I put, so that would become as a 3 into 2 into 10 raised to power 11 into 84,000 10 raised to power minus 8 divided by 6. That height is 6. 3 plus 3. Okay, 3 plus 3 is the 6. 6 cube. So that will be coming out to be, uh, if you solve this, that is a 2.33 into 10 raised to power 6 Newton per meter. It will be coming like that. Or you can write it as a 2.33 mega Newton per meter. Okay. Similarly, K2. So your K2 would be also 3i by 3i2 by L2 cube. But here we have the two columns, so that will multiply with the 2. So it would be 6 times 2 into 10 raised to power 11, 11, 42,000 10 raised to power minus 8 divided by L2 is what? L2 is 3 cube. So if you solve this, you will be get 18.67 mega Newton per meter. Okay. Similarly, K3. In this K3, it would be 2 into 12 EI 2 by L2 cube. So it would be 24 into 2 into 10 raised to power 11, 42,000 10 raised to power minus 8, 3 cube. So it will be coming out to be 74.67 mega Newton per meter. Okay, and the masses you have given, the m1 is given to as 72,000 kilogram, and m2 is given to you as a 110,000 kilogram. So we will, our mass matrix is that 72 0 0 110 10 raised to power 3 kilogram. Okay, similarly our stiffness matrix would be, if I will put the each value k1 k2 k3, I will get 93.34, 74.67, 74.67 plus 77 into 10 raised to power 6 Newton meter. So if I do the eigenvalue problem, k minus, now this problem become easier, k minus lambda m. If you do that, so the my final equation is coming out to be 7920 into 10 raised to power 6 lambda square minus 15 811.4 into 10 raised to power 9 lambda plus 16 11.57 10 raised to power 12 is equal to 0. So if you solve this, you will get lambda 1 is equal to 107.74 and your lambda 2 would be 1888.65. So from this you can get your omega 1 as a 10.37 radian per second and omega 2 is 43.65 radian per second. Okay, so now you can get the mode shape. So if you go to the mode shape for lambda 1 is equal to 107.74, your mode shape phi with the normalization of the degree of freedom 2, we are getting it as a 1.8725. Okay, and with lambda 2 is equal to 188.65, your phi 2 is coming out to be minus 1.75111. So that is the uh, for the part A, like the equation of the motion and the model properties. Okay, now we need to go with the part 2, in which we need to find out the peak drift column. Okay, so for this, part B. Sorry. So part B, to find out the peak drift, we need to find out the peak column drift due to seismic excitation. Okay, so for this, we will first find out the what is our time period t1. So that is 2 pi by omega 1. So if you do that, it will be coming out to be 0.6053 second, and for t2, 2 pi by how much it is, 43.65, so it will be coming out to be 0.1446 second. So corresponding to this t1 and t2, if we go and look into this, our t1 is what, 0.60, so our t1 is lying in this t1 and our t2 is lying in this. Okay, so for this, our s1 become as a zero point 0.5 by t1 and our s2 is become 1. Okay, so if we go from the spectra, so our s1 was what, zero point 0.5 by t1, so that become zero point 0.5 by 0.6053 z, also multiply with the g. Okay, and that s2 is simple 1g. So if we calculate a1, it will be coming out to zero point 0.5 0.6053 times 9.81. So if you do that, you will get it to be 8.103 meter per second square. Similarly, you can get the A2, that is the 1 into 9.81. So it will be same as 9.81 meter per second square. So now after A1 and A2, you can get the D1, D2 model displacement. So that is the A1 divided by omega 1 square, so that is 8.103, and omega 1 is how much? That is 10.37 square. So if you do that, you will get it 0.07535. Okay. Similarly, you can find out the d2, so that would be also the a2 by omega 2 square, so that is 9.81 divided by 43.46 square, so that coming out to be zero point 0.0. So those are in the meter. Okay, 0.051938 meter. You can write it into the centimeter, but these we will write later. So now after doing that, we need to determine the model participation ratios, participation factor. Now we need to determine the model participation participation factor. How do we that? That is the gamma 1 is the phi 1 transpose time mass matrix time the influence vector divided by the phi 1 transpose mass matrix times phi 1. So here our influence vector would be L is equal to 1 1. Okay. How do we this is that we have discussed in the earlier classes also. So we are not going to discuss that. So 0.875 1 mass matrix, you can keep it here, 75.50. So it would be 8725, and if you do that, your mass matrix is, what is your mass matrix? That is 72,001,110 into 10 raised to power 3 into 1 1. Okay, divide by same 0.8725 1 same 72,001,110 10 raised to power 3 into 0.8725 1. If you solve this, you will get it like, how much will you get? You will get it 1.0486. Okay. Similarly, you need to find out the gamma 2. So for the gamma 2, so for gamma 2, it would be again phi 2 transpose mass matrix time L over phi 2 transpose mass matrix time L phi 2. So it will be coming out to be, so your phi 2 is how much? That was a minus 1.75211, not 2, 1 1. Then it is 72,001,110 10 raised to power 3 into 1 1. So if you do that, you will find it out as a minus 0.0486. Okay. So now you can find out the modal response after getting that modal response. Okay. So for this, your Q1 would be the gamma 1 time the D1. So your gamma 1 is what? 1.0486. Your D1 is what? It is 0.07535. So you will get it 0.07901 meter. Similarly, Q2, that is gamma 2 D2 minus 0.0486. multiply with the 0.0051938, so it will be very less. You can ignore it if you want difficult, basic difficult in that, but here we are considering meter. Okay, so you can find out the displacement of the stories. Un is equal to phi n time un. So your u1 will be the u11, u21 would be phi 1 is how much? That is 0.8725. Time q1 is how much? 0.07901. So if you do that, we will getting it is a 68.93 plus 79 mm. We converted it into the mm. Okay, initially it was in the meter. Okay, so we multiply with the 10 raised to power 3 also. Similarly, for the second mode, that will be the u12 u22. If you do that, it will be coming out to be minus 1.75111 into negative 0.002524 into 10 raised to power 3. If we do that, we will get the displacement as 0.4419 and minus 0.2524 mm. Okay, so now we need to find out the story drift, not the displacement drift. Okay, means did you mean the drift? Did you know? For like the story displacement is that?
Displacement is from base, na,
Yes,
and drift is relative.
relative. Yes. So like this is your displacement for this, and this is your total displacement u2. Okay, so for the first story, whatever your displacement is same as your drift story. So for the first drift would be u1, and for this your drift would be the u2 minus u1. Okay, so for the first story or the first mode, your delta 1 we are calling delta as a drift. Okay, delta 2, delta 1, not the delta 1 delta 2, because that would be, but we are calling it as a delta normally. So delta 1, like in the drift in the first story, first mode. So in the first mode, that would be the how much. So if you find out the drift, so for the first story in the first mode, for the first story, what would be the drift? Using that, can you give me the drift value? Can you give me the drift value using that?
68.93.
Yes. For the first story, it is a
Yes, for
68.93,
uh,
and for the second one, it would be,
there minus 79 minus 68.93.
so that would be the 10.08. Is it right?
Yes, actually, I don't have calculator right
No,
now.
like, but the approximation is like that.
Yes, 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 sir.
So now for the second mode, delta 2, for the first story, it would be 0.4419. Okay, and for the second story, it would be the minus 0.25 and then the minus 0.44. So it would be minus 0.6943. Is it okay? Any doubt or okay?
Uh, Second minus first. Okay, okay.
In this, what happen? Your mode is like that. It would be like that. Okay, so if you you will take the relative, so overall how much it would be. So that is
Yes, yes, yes.
that. Okay, so your delta 1 delta 2. So now you need to find out the peak column drift. So for the first story, so this is for the first, second. So for the first story delta 1, it would be the delta 1 1 square, delta 1 2 square, delta 2 1 not 1 2. So it would be 68.93 square plus 0.4419 square. So it would be coming out to be 68.93 mm. Okay. For the second story, delta 2, it would be delta 2 1 square, delta 2 2 square. So that would be 10.08 square plus 0.6943 square. So that is coming out to be 10.104 mm. So these are your peak drift. Okay. Now we need to find out the part C. What happened? तू है क्या? लेक्चर चल रहा है, आजा बैठ जा थोड़ी देर और 10 मिनट 15 मिनट. So that's for the second story. Now we need to find out the response for the part C. So we need to determine the in the part C we need to determine the peak internal forces, peak forces in column. Okay. So for this will determine the story forces. So story forces, how do we determine forces? That would be the F1 time omega n square time gamma n time mass matrix time phi n time dn. I don't need to discuss this. Do you need to discuss this? How do we get it? Or it is clear in the previous lectures?
Actually, I have forgot, but I will study, sir, later.
Okay, okay. So yeah,
Mm.
this is like simply your F1 is equal to omega like k time u. Okay, so you can write it k as a omega n square time m, and you can write as a gamma minus you will be right you can be right phi time q. Okay, and q can be your, am I audible?
Yes, sir. Yes, sir.
Okay, or your q will be the
Okay, means stiffness multiplied by displacement, and then
gamma
we are
time
replacing
dn.
this.
So that would be the phi gamma dn. Then you need to only rearrange the terms, only thing. Okay,
Okay, sir. Okay.
so this way you can get it. So now after getting this, you can directly get the for the first mode f1, that would be the 10.37 square times 1.0486 square mass matrix your 75,001,110 10 raised to power 3 into, can you am I audible? Yeah, now I think,
Yes, sir. Yes.
because okay, that will become 0.8725 into your displacement was, what was that, d1, that was 0.07535. So if you solve this, you will get, I will divide it by the thousand also to convert it into the kilonewton. So that will become 533 and 934.64 kilonewton. Okay, similarly we can get F2, so that would be 43.46 square into 0.0486 into mass matrix 75. That would not be 75 actually, that would be 72, but the calculation is correct. That would be 72. Okay. So 72 into 0 into 0 1110 into 10 raised to power 3 into minus 1.7511 1 into 0.0051938. So, and I am dividing it by the 10 raised to power minus 3 to convert it into the kilonewton. So it would be the 60.11 52.44 kilonewton. So these are the forces. Now you can calculate the shear force. So in the first mode, you have the forces as 533.76, 934.64, and in the second mode, you have the forces 60.11 and minus 52.44. Okay, so you can get for the first story we need. So for the first story, your shear force would be V11. It would be the sum of this 533.76 plus 934.64. So it is coming out to be 1468.4 kilonewton. Okay, and for this it would be over minus 52.44 plus 60.11. So it will be coming out to be 7.67 kilonewton. So your base shear would be V11 square V21 square. Okay, V12 square. Okay, so it would be 1468.4 square plus 7.67 square. So it would be coming out to be 1468.42 kilometer. So from this you can observe that if you ignore the second mode, then it will be not much affecting, because it is like very like negligible, around 1 to 2% effect, because all the forces are dominant from the first mode. So that's how you can do your calculation easier. So that's all for this question. If you are having any doubt, you can ask from this question. Any doubt?
No, sir. It is clear.
Okay. Not if you don't have any doubt from this or from the previous one, I'm here for the next 5 minutes.
Okay. Actually, I have only one doubt that for dynamic analysis, there is a response spectrum method is there and time history is there, right? So, what is the means difference between these two? Means in response spectra, we are considering the particular earthquake and we are considering the peak responses with respect to that time period. So, what we are doing in time history, sir, you are not audible.
Now, now I'm audible.
Yes, but it is not loud.
Wait. Sorry. Now,
It is audible, but it is okay. Try to speak. I will hear it once.
okay. So you are asking for the time history. like time history analysis is the like the very good estimation of the finding out the response. Okay,
Yes.
but the response spectrum is like, but time history is the like the time costing, like time, like it will take longer time. But for the response spectrum analysis, it is not that much good as the time history analysis. But in that you do not need to any like the, it is not time consuming. In the response spectrum analysis, you have the like from for the all the time history, you can make the your response spectra for your whatever corresponding to your target spectra. On like for the target spectra, you design your structures, but for the time history,
Okay.
you get your actual response of the structure particular. But in the response spectra, you are focused only on the maximum, like what is happening on that particular maximum time period or something else.
Okay.
So in the most of the cases when we do the analysis, we prefer to the time history analysis. But some of the cases like where we do not need to the whole scenario, only for the design purpose, sometime we directly use the response spectra. So it will give the directly maximum forces on base here, so on
Mm.
so that we can design.
Means, one of my friend told me that time history they do only for the structure. Those are very important. Like that.
That depend like important. If you are designing, every structure is important. Like important is meaning what, like you are doing for only the important structure such as hospital and some kind of structure.
Yeah, like thermal power plant and like that.
No, but every structure is important. So nowadays everyone is doing the time history analysis.
Okay, okay. Means everyone following it.
Yes, not that much,
Okay,
but now they started like everyone.
okay, sir. Okay,
So you can do that whatever. You can compare with the results also, like variability, how much variability it is coming for the time history in the response to the response spectrum
okay.
analysis. That's all. So any other question?
No, sir. No.
So okay, so this was our last session. So if still you have
Okay,
any doubt, you can post on the Google form, like that discussion form, or yeah, I can check your questions from there. No need to do personal mail. I will look into there.
okay, sir. Okay. Thank you so much for all the sessions.
Okay. So, take
Mm,
all the best for your exams. So when is your exam?
I think it's on 28.
28th. Okay.
Yes,
All the best.
yes. Okay. Thank you, sir. And happy Dasara and happy Diwali in advance.
Okay. Okay. Same to you.
Okay,
So
okay, sir.
now, if you don't have any doubt, you can leave the session.
Okay, sir. Okay. I am leaving. Okay. Thank you.
Okay.